Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 15. So before beginning this question, first of all, congratulations to everyone who have maintained their pace till now. Today we complete the first 15 days of the December daily LeetCode challenge. So if you have been consistent till now, really great congratulations to all of you because it was not easy journey. We were having easy to medium level questions till now. We have not seen the hard level questions, but yeah, I will still say like it definitely needed a big courage to continue in this journey. So definitely big congratulations to all of you who have maintained your pace. When I say maintain your pace, I meant either you should have learned something else, even if you're not able to solve, at least you should have learned something new. Okay, you should not repeat the same mistake that you've done. If you're at least able to ensure that, then also you can be proud that yeah, you have done something at least for your career in this first 15 days of the December. So big congratulations once again. And coming to today's question, it's again a very very good question, but here there is some angle for mathematics as well. So you have to be slightly good in terms of mathematics to able to understand this question fully, because this involves right mathematics to understand how the approach should be designed. Okay, so it's all about that. I will show you the whole thing here, and let me do this very proudly. The solution that I will be showing you is even better than the lead code solution. Okay, the most optimal possible lead code solution that is available. My solution is going to be better than that. Okay, with that, I want to start this video. So let's quickly dive into this question. It's question that is it's day 15 of the December daily LeetCode challenge 1792 maximum average pass ratio. Okay, so if you see here, basically see here each class. Let me go through the input first, then we'll go to the actual theory of the question. Okay, it's a very big one, so I'm not expecting to read everything, but I will give the link so that you can go and refer it on your own. But I will just go through the important points. So basically, this is how. Okay, let me zoom in first. If you see here, this is the definition of a class. That is the two variables that you're seeing. This is going to be one element. Okay, in our classes. That is, this is representing a single class. Okay, this is the class 1, this is the class 2, and so on. Okay, this is the class 3 and so on. So each class basically has two values. Okay, for example, in the class 1 there are two values, 1 and 2. So what are those values? What is the meaning of that values? The first value represents the number of students who are going to pass, and similarly the second value represents the number of total students in the class. Okay, so if you talk about the class 1, so see, this is the class 1, right? The first value represents the number of students that are going to pass. The second will represent the total number of students in the class. Okay, similarly for class 2, the 3 represent the total number of students that are going to pass, and this 5 is the total number of students in the class. So out of 5, 3 are going to pass. Similarly, here out of 2, 1 is going to pass. Okay, and so on, right? That is what they're trying to convey. Okay. So now the question here is, see, here we are talking about something called the pass ratio. Okay, we are talking about the pass ratio. So let us try to understand. See, for first of all, each class will have a pass ratio. What is that? The number of students that are passing divided by the total number of students. Okay, for class 1 it is going to be 1 divided by 2, which is 0.5. Okay, in this the same thing for class 2 is going to be 3 divided by 5, which is 0.6 and so on. Okay, like that. This is called the pass ratio. Pass ratio basically tells me, like, in a class, what is the ratio of students that are going to pass. Okay, what you can say, like, what is the I will not say percentage, you can say like it's a fraction of students that are going to pass. Okay, as simple as that. Yeah, that is the pass ratio. Now they are asking you to find the average pass ratio. That you have to maximize this. Okay, the average pass ratio you have to maximize. So what is the average pass ratio? Let us try to understand this. See here. Now please pay attention here so that you can understand every bit of this question. Okay, I've done a lot of homework for you to explain you something good. Okay, I've done a lot of work here, so please pay attention. I'm damn sure that after watching this video, you will have everything that you need to understand this question and the best possible solution available for this question. Okay, that is my guarantee. So please pay attention to this. See, I will go to in detail of it. See, first of all, what is the pass ratio of this? It is going to be 0.5. Okay, what is the pass ratio of say? It is going to be 0.6. Okay, what is the pass ratio of this? Is going to be 1. Okay, 2 divided by 2 is 1. So now if you add all the three pass ratios, that is 0.5 plus 0.6 plus 1. Okay, some value will come. Now you have to divide the, like, all of these are individual ratios and all that, but we want the overall ratio. Okay, so we'll have to divide the sum. Okay, what we got is 0.5 plus 0.6 plus 1 divided by 3. Why 3? There are three classes here, so we'll have to divide that by 3. The answer that comes, that is something that you have to return here. Okay, that you have to return. Fine. But the trick here is that they are saying that, okay, first of all, I hope you are now clear what is the average pass ratio. Okay, pass ratio is there for each class. If you talk about the overall average pass ratio, that is the average pass ratio. You see here, they are defining here is the sum of the pass ratios of all the classes divided by the number of classes. Okay, they are mentioning that. Okay, now they are saying maximize the maximize. Okay, return the maximum possible average pass ratio after assigning extra students. Okay, this many number of students. Okay, answer within 10 or 5 of the actual answer to be accepted. Okay, fine. Now let us see what is the trick now. See, if I if this part is not there, then it's not a question, right? It's totally maths after that. Okay, but there is a trick here. Now they're saying that you have certain students. Okay, they are not part of any classes up now. Okay, you will have to assign them a class in such a way that after assigning them to a particular class, first of all, like, see, these are the students who are very, meritorious students. That is, they will always pass. It is guaranteed that these students will be passing in whichever class they get into. Okay, that is the first thing. Next thing is that after you include them in such a class, what will happen? See, the number, this particular number will increase because the number of students that are going to pass will increase in that class, and the total number of students will also increase after assigning these students to a particular class. Okay, remember that part. Now, what will happen is that ratio will now change. For example, if I assign them to this, the ratio will now change. Similarly, I can assign them to this class also, or I can assign them to this class also. I can assign them to any class that I want. Okay, but what they are saying to find the maximum possible average. That is, we have to assign them in such a way that the average, okay, the average pass ratio, that is overall average pass ratio, is maximum possible. That is the question. Okay, so I hope you understood the question. I will quickly go through the diagrams now, so that you understood the every possible thing here, so that you don't have any after that any doubt of why this is happening. Okay, I've done a lot of work here, so please, like, it's my request, please pay attention. I'm sure that you will be able to get something good out of it. Okay, so let us begin with this. So see, I am keeping the example one in the left side, and this is the tracing that I'm showing you. First of all, like, see, I'm not talking about class one. See, like, my current the thing that I want to show is that let us see the calculations what is there, so that it will help us decide which class we should add the first student. Okay, we have actually two extra students. Now I'm talking about only the first extra student. Okay, we'll now try to assign it to a particular class, and we'll see how their calculations are helping us in that. Okay, we'll see that. So this is the class one, by the way. Okay, this is the calculation for the class one. See here, class one, currently the pass ratio is going to be 1 divided by 2. Okay, if you see, it is going to 0.5 currently. Okay, now if I add a student in this, okay, what is going to happen? If I add a student, that is, if I add a merit to a student, what will going to happen now? The pass, that is the number of students who are going to pass, will increase. The total number of students will also increase, so it will become 2 by 3. Now I hope you are clear now. See, there should not be any doubt in this. 1, if you do a plus 1 here, it will become 2. Okay, similarly, if you add 1 to the denominator, it will become, from 2 it will become 3. Okay, so 1 you have to add to both the numerator and the denominator, then it will become this. Okay, now if you take the ratio, this is going to be 0.66. Remember, this is only for a class 1. I have not discussed other classes as of now. Okay, so this is 0.66. Now if you talk about the difference that is going to come, see, this was the previous ratio, this is the new ratio. Okay, if I add a student, remember, till now I have not added. So what is the diff that is going to come? Diff is going to be 0.15. How I'm getting that? Subtract, like, 0.66 minus 0.5 if you do. Okay, basically that is how you have to do. So, okay, just a second. Yeah, it is 0.5. Yeah, it is 0.66. Okay, yep, it should be 0.16 basically. Okay, not 0.15, it should be 0.16 basically. Okay, yep, if you subtract, yeah, you are going to get, yep. Yeah, fine. It's 0.16. So this is the difference that is going to come. Okay, it's in the positive way. That is, previously it was like this. Now after adding student, it becomes like this. So this is the difference that I'm going to get. Remember, this difference is going to tell us how much, by how much amount, the final answer, that is the overall pass ratio, is going to increase. Okay, that is something that is going to tell me. Okay, if I divide it by 3, that will tell me the actual amount by which the answer is going to get increased by. Okay, now let us talk about the class 2. Let us say the currency. If you talk about class 2, it is 3 by 5. Okay, 3 by 5 is 0.6. Fine. If I add a student to this class, what will happen? It will become 4 by 6. So 4 by 6 is 0.66. Okay, now if you take the difference, okay, 0.66 minus 0.6, you are going to get basically 0.06. Now, which is greater? Definitely this is greater than this. Okay, do you agree with me in that? So the idea here is, if I add a student to class 1, the see, the advantage that I'm going to get, that is the, see, my ultimate aim is to maximize the final answer, right? So the diff that is being generated if I add a student to class 1 is much higher than the diff that I'm going to get if I add a student to class number 2. Okay, so my, see, it's very clear now. See, class 3 I'm not discussing at all, because see here, the diff is not going to change this. Let me tell you this, you can do the calculation on your own. See, the ratio is going to be 1 divided by 1, which is 1 only. Okay, so the pass ratio is going to be 1 itself, and even if you add a student, again the pass ratio will remain 1 itself. Okay, so there is no change happening in that, so it's not going to help us in any way. The answer will remain as it is only. Okay, the receipt will remain as it is only. So that's why I'm not even discussing about this particular thing. Okay, I'm only discussing about class 1 and class 2. Okay, as simple as that. So if you compare among these two, see, this is the class 2 diff, this is the class 1 diff. So now it's very clear that the class 1 diff is much higher than the class 2 diff. Okay, for that reason we can conclude very carefully that, yeah, class 1 is the most ideal class to which we can add the extra student, such that the final answer will be maximized to the maximum possible. Okay, as simple as that. Now let us say we added it. Okay, we did that thing and we added it. Okay, it's best to add a student of in class 1 as class 1 having the highest diff. Okay, as simple as that. Now after adding a student in the class 1, remember that when you are, see, there are two extra students, right? After adding one student, that is when you're going to add the second student, you will have to consider the previous student that was added. Remember that. That is when I'm going to add the student number 2. Okay, I will have to take into account the addition of student number one already. That is, if you see here, these ratios will now change. Previously it was 1 by 2, okay, before I add the student number one. But after, let's see, now it is very clear that the student number one is should be added in class one. That is, this particular ratios will now change. Okay, so this will be the ratio now for the new calculation. That is, if you see here, after adding student in class 1, this is going to be the ratio. See here, it was 1 comma 2 previously, now it will be 2 comma 3, which is 0.66. Okay, now I have to redo the calculations again. So that is, if you see here, now I have to again calculate the new diff. Okay, this is going to be 2 comma 3. I'm talking about the second student now. If I have to add the second student, what is the advantage that I'm going to get? See, if I add one student to this, the ratio is going to be 3 by 4, which is 0.75. So if you see here, if I subtract, that is the diff. If I calculate from 0.66 to 0.75, it is going to be 0.09. Okay, same, but for class 2 it will remain the same. The calculation remains the same because we did not add any students. So the 3 comma 5 here also, it will remain same 3 by 5 here also. So the values that I showed you previously will remain the same here. It is 0.66 here. Okay, if I add a new student, it is going to 0.66. So what is the diff? That is 0.66 minus 0.6. What is we are going to get? We are going to get 0.06. So if you see again, like this diff is greater than this diff. So the idea here is even the second student should be added to class 1 itself. That is the basic idea. Okay, so this is the actual calculation that we will be doing in part of this question. Okay, and let me tell you, I will again to like come to the point why my solution is even better than LeetCode solution. We'll come to that also, but quickly let us begin the solution for now. So I hope you are very clear now with everything. Let us begin now. So see, this is going to be my this is going to be the sum of fast ratios. The final answer will be sum of fast ratio divided by n. Okay, if you see here, this is going to be the answer. Finally, I will just divide it by n. So this is going to be the ratio. The idea here is we'll have to maximize this as much as possible. Okay, n is going to be the number of classes, and I am going to use a minimum heap. So can you quickly tell me why is the heap needed here basically? So the heap is needed basically to track like class is going to have the highest diff. That is, we will simulate if we add a student to every class, what is the diff that they are going to generate. That is the new value minus the current value. Okay, that is the new average minus the current average. So that is the diff. So we'll add the diff for each class in our heap. That heap will tell me which is the highest diff and which class it belongs to, and accordingly we will be adding the student to that class. Okay, so for that reason we need a heap. Okay, fine. Now what I'm doing, I'm going through each student in the class. That is, I'm going through this particular array. Okay, the first parameter is called the pass student, the second one is the total students. Okay, first of all I'm calculating the pass ratio. This is going to be the original pass ratio, remember that. This ratio I'm going to add it to my sum of fast ratios. Okay, remember this is where my solution is going to perform better than LeetCode, because remember in lead that is, yeah, in the LeetCode optimal solution, what they're doing is at last, that after after processing the heap, they're recalculating, they're revisiting the heap and they're calculating the values. Okay, but in my case I'm calculating them as and when we are seeing them. Okay, as simple as that. Now see here, this will be added. Fine. Now at the same loop itself, in the same loop itself, what I'm doing, I'm calculating the new ratio also. Okay, if extra student is added, what will be the new pass ratio? So the new pass ratio will be like this. Okay, that is just add one to the pass students, just add one to the total students. Okay, get the new ratio. This is going to be the new ratio. Now get the diff. The diff is going to be the new pass ratio minus the original pass ratio. Original pass ratio is this one, remember that. Okay, so this is the diff. Now I'm going to push it into the diff. But one point, if you have been following my video from the last few days, I'm damn sure about it that, see, this is a heap. Okay, heap in Python and even in Java, remember that in all the popular libraries, what is happening is they are implementing only the minimum heap. Okay, that is only the heap will basically pop the smallest value only. Okay, so this is a min heap, but we want it to behave like a max heap because we want the max diff. Remember that in our scenario we want the diff which is maximum. Okay, not the minimum. For that reason, when we are inserting into the heap, we will add it with a minus sign. Okay, that is something that you have to remember. So this is basically going to be the element that will be inserted to the heap. Okay, so what are the three parameters here? First is the diff itself. Okay, I will, okay, as you can see, the diff is calculated. Now I will push it to the heap. Okay, so what I'm doing, see, this is going to be the whole element. There are three parts here. First part is the diff itself with an active sign. Okay, let me just enlarge this part. Yep, first is the diff itself with an active sign. Second is the number of past students here now currently. That is, after I add this new student to this, the number of past students will increase by one. Similarly, after I add a student, the total number of students will also increase by one. Okay, as simple as that. The idea here is if I have to consider this diff, I will have to do this also. That is, I have to take into account that a student is added to this class. Okay, as simple as that. The negative sign is for simulating the max heap. So I added the comment also here. Okay, fine. So fine, yeah, like this print statements are just for you. You can maybe enable them when you are taking the solution. You can do that part also. Fine. Now after I come out of this particular for loop, the idea here is after this the whole heap will be populated. Okay, you can see here I'm using a heap push. I'm pushing these values. This is going to be a single element here. Okay, as simple as that. Fine. Next, what I'm doing now, for each extra student, basically I have to add it to a particular class. Okay, as simple as that. For that, what I'm doing, see, first of all, I have to do a heap pop. Heap pop will basically return me the student which is having the highest diff. Remember, the class which is having the highest diff will be returned. Okay, so that, remember, a minus sign will be there initial. Okay, so I have to again multiply with this with -1. Okay, so the same value is what I passed. Okay, the same value that I passed. Okay, that will be returned here. Okay, so the past students, the total students, and the max diff. Max diff will have to be multiplied with a -1, because while while pushing it, we'll multiply it with -1. So while popping it also, we're multiplying with -1. As simple as that. Okay, fine. This new diff just added to your sum of ratios. Remember, this is the part where my solution is behaving much better than the lead code solution, because while doing this calculation, that is while pushing and popping, they are not adding it to their sum of pass ratio. That is, for this reason, they'll have to add additional iteration. Remember that part. When you see the solution, you will understand this. But in my solution, here itself, I'm adding them. Okay, this is, as I mentioned, this is again about mathematics. So see, you will have to like derive the equation and see like how my solution is working basically. Okay, the idea here is, see, the actual ratio I calculated here itself. Okay, if you see here, once I come out of this while loop, the actual array that we have, okay, without adding any students, that ratio is again there with me. But from here onwards, I will just simulate if a new student is added, and that part only I'm going to add to my solution. Okay, the diff part only will be added after that. Okay, nothing else. The idea here is, see, if I do not consider this diff, the calculations are already done for me. Okay, I have already calculated the sum of pass ratios for the existing numbers. But when I add a new value, this diff is the extra part. Remember that. So only diff I will be adding to my answer after that. Okay, as simple as that. So for each extra student, what I'm doing, I'm just popping the value. I'm adding the diff. That is, it's the maximum diff. Remember that. That's why the name is given max diff. I'm adding it to my pass ratio. As simple as that. Okay, the sum of pass ratio, I'm adding it to that. Next, now I will have to simulate. Like, see, it is very simple, right? Uh, See, try to understand, one student is added, but for the next student, the class, I have to again, like, I have to prepare these calculations, right? I will have to again prepare these calculations, like what is the diff now for this particular class after adding the student. Okay, as simple as that. So since, like, see, this class, okay, the number of students have now changed because one student is added. So for the next student that I will be adding, I have to redo the calculation, that I have to redo the new diff calculation. I will have to calculate the new diff again for this class. Okay, before I go to the next iteration of this. Okay, this student is added. Student number 1 is added after this. Okay, for the student number 2, before the student number 2 is added, I will have to redo the calculation for the class in which the student number 1 is added. Okay, as simple as that. So that's what I'm doing. If the extra student is added, what will be the new pass ratio? Same calculation I'm going to do again. Okay, so these are the ones. Okay, this is the past student, this is the total students. Okay, just add one to them, add one to the total students also. Let's add one to the numerator and denominator and get the new pass ratio. Okay, in the new pass ratio, like, subtract the original value. What is the original value? Original value is the past students divided by the total student. Okay, you will get the diff. Now this diff should be added. Okay, this part what you are seeing here is exactly same as the this part. Okay, both exactly same. There's nothing different here. Okay, I'm adding a negative sign and then I'm pushing these past students +1, total students +1. Okay, as simple as that. And now after this, I can go to the next iteration where I will be adding the second student. That is, for the current, the class in which a student is added is now ready, that I have a diff now ready for it. That will be considered when the next student is added. Okay, as simple as that. Now this loop will continue till we have extra student. Okay, and after that, all the students will be added. Finally, now my sum of, pass ratios, I will have to divide it by n to get the average. This average is guaranteed to be the maximum. Okay, see, that is about the question. Return the maximum possible average pass ratio. Okay, after assigning the extra students. So this is going to be the maximum possible average ratio, as simple as that. Okay, so you can go through these calculations. I'm damn sure that you will find them relevant. And I've tried my maximum, like, I am not using any pen or pencil to show the calculations, but as much as possible, I am doing it so that I can write at every step what is happening, so that it's very easy for you when you like take this comment from the comment section of the video. Okay, as simple as that. Now coming to space and time complexity of it. See, we are using a heap, so obviously the space complexity is going to be often, that is very obvious. Now coming to the time complexity. So see here, basically, if you talk about this loop, what is happening in this loop? In this loop, we are pushing a element. That is, there are, see, this loop will run for n iterations. In each iteration, we are doing a push. Okay, so it is going to be n log n times. Okay, the complexity is going to be n log n times for the first loop. Okay, this is this part. Now for the second loop, if I come into, okay, the second loop is this. If this loop is going to run for k times. What is k? K is going to be the number of extra students that are going to be added. Okay, here in each iteration, basically, we are popping a value. See, popping and pushing both, ideally, see, we are also popping a value, at the same time we are pushing a value. But since both of them are having the same complexity, I will consider them only once. Okay, so at each iteration of this, that is, there are going to be k iterations. In each iteration, we are doing a push and pop, which is log n time. So this particular, that time comes from this whole loop, basically will be k log n times. Okay, so this is k log n times, this is n log n times. Okay, as simple as that. So this is going to be your time complexity. Like one more thing that you can do is, if you just compare what is k and n, k is going to be, see, the class length is going to be n, and the extra students length is going to be k. That is, yeah, extra is going to be k. Okay, if you see here, the max limit is same for both of them. So basically both k log n and log n are treated as same. Okay, so basically you can write this as equal to o of n log n. Okay, because k and n are same, so it doesn't make sense to write them separately again and again. You can just write o of n log n because their max values are same. Remember, when we're at the o of, that's big O limit, we are considering the max. That's the worst case scenarios. Okay, so for that reason, you can just write big O notation. In terms of big O notation, they are the same. Okay, as simple as that. So yeah, often that was all for this question. This question was slightly on the trickier side. I understand that, because yeah, if you are not, so first of all, it involves a lot of calculations. Okay, without a pen and paper, I don't think you will be able to do it, because you will have to compare these things. Like why the diff are changing, like why the decision to take the diffs is coming from here only. You'll have to like do this divisions, get the values, and then analyze which is the best to add. Okay, and then you will realize that the whole situation is going to depend on diff. Okay, the mistake that most students can do here is that they will think that, okay, the one which is having the lowest average, let me add a student to that. Okay, that is not the right case. That is not the right case, because see, after adding a student, the ratios will again change. So for adding the second student, we'll have to recalculate the ratios. Okay, simple as that. And moreover, it's not about the ratio. Remember that it's all about the diff. Okay, how much the diff is changing, that is going to influence the answer. Okay, the most. Okay, it's not about the ratio. Okay, that's something that I want to tell, because here they're asking the maximum value, right? So for getting the maximum, what you have to see is which diff is changing the most. That's it. Which after adding student, the ratio will now change. And now we have to calculate the diff of it. That is the new ratio minus the original ratio. How much difference is coming? The one which is giving the highest difference, that is the class which is giving the highest difference in the ratios, should be added. That particular class should be given a student. Okay, as simple as that. So that was the logic that I used, and I got the solution. I used the heap for that. Okay, to get the max diff class. Okay, from to which we can add a student. So yeah, and that was all for this video. I'm not again solving it in Hindi, because like I have given a lot of explanation here. I've like already crossed like I guess 10 or 15 minutes to make this video. So I'm not again making a Hindi video for this, students. Like if you have, like if you need a Hindi video, please do let me know in the comment section. I will make it. But I feel like I've given a lot of explanation here. So like it will take like again same amount of time for me to make a Hindi video. So I'm not doing it currently. And one more thing, today we already also had the weekly contest. In this is Sunday, right? So we already had the weekly contest for this. I am also going to upload the solutions for that. So let me know in the comment section what was your thought regarding the difficulty level for today's contest questions. Okay, I mean the question number 1, 2, and 3. That is that should be your target basically. Question number 1, 2, and 3. I'm not talking about the question number 4. So just let me know in the comment section your thoughts on the difficulty level for the weekly contest question number 1, 2, and 3. Okay, I will be putting videos for them also in some time. So yeah, and that was all for this video. See you tomorrow. Thanks a lot.